Hello, everyone, and welcome to another episode of Vibrations, a TMC podcast. I'm your host, Daniel Litwin, the voice of B2B. Folks, thanks for joining us on another episode of the show as we dive deep into the world of precision technology, vibration control technology, and the industries that rely on them. Today, we've got a very special episode. We're broadcasting from the heart of innovation, the Microscopy and Microanalysis annual meeting in Minneapolis, Minnesota. A lot of M's there for you. This is the M Mecca, another one where industry leaders and pioneers gather to showcase the latest advancements in microscopy and microanalysis. Why is this important, though? Well, because the tools and techniques discussed here are the bedrock of scientific research and industrial applications, from healthcare to nanotechnology. So while we're here at the show, we wanted to take an opportunity to share some of our new technologies, our mission, and how we're playing a key role in supporting these critical industries. So in today's episode, we're going to delve deep into our groundbreaking stasis technology, the most advanced way to filter out floor vibrations. We're going to introduce you to the Stasis 4, the next-gen system that's setting new standards in the industry. And of course, you might be asking, why is this timely? Well, because as the world demands higher resolutions and more precise measurements, the need for unparalleled vibration isolation has never been greater. We're going to connect all those dots here with our conversation. So joining us today from the show floor is Mr. Stephen Ryan, Vice President of Sales and Service for TMC and Amatech Business. Stephen, great to have you joining us, man. Thank you again for taking some time out of your busy schedule at the show. So again, you're on the ground, you're posted up, right? Tell us more about what's going on today.
We're at the Microscopy and Microanalysis annual meeting in Minneapolis, Minnesota.
Sweet. Thanks for that context, man. So let's jump in. Again, can you briefly summarize what TMC is and what we do for the uninitiated?
TMC designs and manufactures advanced vibration isolation systems. What we do is we isolate building floor vibration from disturbing ultra-precision instruments, experiments, and manufacturing processes. So we do this products that take different sizes and shapes, from tables to floor platforms to custom vibration isolation modules that are built into machines.
Obviously, TMC is a B2B company, but I want to ask, just so that our audience understands who, especially in relation to this show, is giving y'all a call, right, when they need a vibration isolation solution. Give us an example of a typical problem that a customer might call TMC about and how that relates to y'all's overall mission.
Our customers fall into a wide range of industries and applications. But one example might be something like, imagine Columbia University in Lower Manhattan. Someone might be doing research on 25th floor, and they might have an electron microscope that's magnifying an image by up to, say, 1,000,000 times, and doing extremely high resolution work with resolution all the way down to a nanometer or less of resolution. Well, this building might be over a subway line. It's in Upper Manhattan, so there's a tremendous amount of construction activity, street traffic, again, subways, wind, and the effect of these vibration inputs is to limit the resolution, limit the amount of resolution that can be obtained at high magnitudes. So by isolating such an electron microscope, isolating it from the building floor vibration, we're able to allow the tool to achieve its maximum performance level.
Well, like I mentioned earlier, the main technology we want to get a little more perspective on today is the Stasis and the next generation of y'all's Stasis product. So can you give us a brief description of Stasis as a product line, and to start with the technology more specifically, because that's really the most important piece of the puzzle.
So the Stasis technology is the most advanced way to isolate building floor vibrations from vibration-sensitive instrument. And the way it works is by having vibration sensor that measure the velocity of the floor in the horizontal and vertical axes. We take that signal, we condition that signal, and amplify it, and in the different axes we're expanding and contracting the piezo stacks very, very quickly. And this is able to filter out floor vibration from reaching the isolated surface. So you can imagine as the floor is moving up and down, we're sensing that, and we're expanding and contracting the piezo stack so that that vibration doesn't get through to the vibration sensitive surface. And of course we're doing that not just vertically, but horizontally, and pitch and roll and yaw all at the same time.
And the stasis has a long legacy, right? We're now on stasis 4. So can you give us a brief description of why the stasis 4 is such a special upgrade? What does it bring to the table?
Yeah, stasis 3 for many years has been the industry standard, really the gold standard on how to get a high level of low frequency, low amplitude building floor vibration isolation. But as customers in all sorts of industries with all sorts of tools keep advancing their research and getting higher and higher resolutions and looking at smaller and smaller features, we find that our customers need ever quieter sites, and it's not always practical to find a quieter site. So they need higher levels of vibration attenuation, and that's what we're able to do with Stasis Floor. With some of the advanced features, including floor feed forward, we're able to isolate down to much quieter levels even than stasis, which had been the gold standard in vibration isolation.
Now, if you had to reflect some and look back at the role that TMC has played in the field of microscopy, microanalysis, right? In your opinion, how has TMC helped shape some of the practices and the standards within this field?
TMC's vision has always been to be the world leader in the design and manufacture of these low frequency, low amplitude building floor vibration isolation systems. And as such, we've always seen ourselves as the pioneers to develop the next generation technology, to always be identifying ways to achieve next level vibration isolation performance. And what we've been able to do is advance all sorts of microscopy techniques. So not just light microscopes, including confocal and super resolution microscopy, but also electron microscopes, atomic force microscopes, scanning probe microscopes, quantum tunneling microscopes, and all of these techniques where customers are really pushing the limits of performance. That's where we're able to really shine. By being able to address the most demanding applications and provide the highest levels of vibration attenuation that are commercially available.
All right, let's intersect Stasis 4 back into the conversation, right? Based on that previous answer, how does Stasis 4 now allow technology to move even further along in this field, right? What benefits does it bring to microanalysis and microscopy specifically?
Well, what's happening is that each new generation of advanced instruments is trying to achieve higher and higher resolutions at higher and higher magnifications. And because they're trying to achieve better resolutions, they're more sensitive to environmental disturbances, especially floor vibration isolation. So given that floors can't be made any quieter than the earth that the building is located on, given that there's this limit to how quiet a building can be, given that it's got people in it, machines in it, HVAC systems, all sorts of background vibration isolation, there's a need for higher levels of attenuation from the vibration isolation systems. So scientists are always trying to get higher and higher resolution of images, right, down to the nanometer scale. And to do this requires each next generation of equipment to achieve ever higher resolutions. And that means that they're always going to be more sensitive to environmental disturbances, acoustic noise, stray magnetic fields, cleanliness, but especially floor vibration. And that means they need to be situated on ever quieter floors, but it's not practical to make building floor vibrations quieter. Ultimately, buildings cannot be any quieter than the earth that the building is built on. So that means the sites need to be made quieter by vibration isolation systems offering more attenuation than was available in the past. And that's what Stasis 4 is able to do. Really the gold standard for vibration isolation from stasis historically was about an order of magnitude at 2 hertz vertically and horizontally, about 20 dB. And with Stasis 4, in some cases, for some of our installations, we've been able to get 2 or even 3 orders of magnitude of attenuation at 2 hertz vertically and about 2 orders of magnitude attenuation horizontally. So it's a dramatic increase in performance to create vibration environments that are dramatically lower than what was commercially achievable before, so that these latest instruments can achieve their full design performance.
this might seem a little redundant, but got to throw it out there. TMC obviously doesn't make microscopes, right? So why are we at M&M today, if you had to really summarize?
Well, the microscope manufacturers come to M&M, the manufacturers of light microscopes and electron microscopes and other types. But there are also a lot of companies here that make equipment and software and other things that enhance microscopy. And that's what we do. We're able to enhance microscopy by providing environmental isolation systems, primarily low frequency, low amplitude, building floor vibration attenuation systems that allow microscopes of various types to achieve their full performance capability.
All right, Steve. Well, thanks for all that context, for giving us some background and vision on stasis and stasis 4 in relation to the M&M Industries. Let's go ahead and get a little deeper on the technology and the specifics of the Stasis 4, but also the rest of the product suite that y'all are showcasing at the show. So, Steve, let's dive in. We've got obviously several isolation systems on display at the show here today. Can you describe each of them and give us a initial, I guess, surface layer analysis here?
So one of the products we have on display here is SemBase. SemBase is a piezoelectric vibration isolation system that uses our stasis technology to isolate scanning electron microscope columns. And we designed these so that they match the footprint and the capacity requirements of virtually every commercially available scanning electron microscope. That's one. We're also showing Stasis, our flagship product, Stasis 4 actually, which is the next generation of stasis performance. And this uses piezoelectric vibration isolators in the form of individual pods that can be placed under platforms to create a large isolated surface. And we're also showing our clean bench tables. These are pneumatic vibration isolation tables in a desk style configuration that you might place a small light microscope on, or a scanning probe microscope, or perhaps an ultramicrotome. These small instruments that would be typically placed on a counter, we're able to isolate them with this desk-style configuration table.
Now, to get a little more specific, can you give us a brief summary of some of the types of applications and use cases that would be used with Stasis 4, right? Or that the Stasis 4 might be deployed for? And how does that differentiate from your SemBase application? They seem to achieve similar goals and deploy similar technology. So what is the difference there? Explain a little more deeply for us.
Yeah, the primary difference between a SemBase application and a stasis application is SemBase would go under a discrete electron microscope column, which would normally otherwise be placed on a laboratory floor or just some sort of a solid floor. Stasis is designed in this pod modular type structure to isolate a platform that can be made of different shapes and sizes that can be customized to the footprint of the instrument that's actually being isolated. So this would normally be done in a raised floor type environment, a raised false floor or computer floor that might be 18 inches tall, 2 feet tall, a meter tall, where we would replace a section of the raised floor with a platform that's made to match the footprint and any utility requirements of the instrument, and then we would support that platform underneath by the stasis pods that are then supported down to the subfloor.
Well, clearly this technology is critical, right? But I'm curious why we don't see more microscope manufacturers just do their own vibration control, right? Why not internalize that part of the technology, bake it into the tech? Why even deploy a TMC as sort of a separate entity and partner in that technology stack?
Well, take electron microscopes as an example. Every electron microscope has a vibration isolation system built in. It's absolutely essential for it to achieve any level of performance. But these vibration isolation systems tend to be what, from our perspective, would be mid to high frequency vibration isolation systems. Because the lower you go in vibration isolation, the more sophisticated and complex the isolation system has to be. So the electron microscopes have what we would consider a modest vibration isolation system built in that would be appropriate for very, very quiet floors, for people who aren't pushing the ultimate limits of the performance of the instrument. But when the site is not a very quiet site, when the site exceeds the floor vibration specs of the instrument manufacturer, or if the customer is really pushing the performance limits, sub-nanometer resolution at 1,000,000x magnification, for instance, they would need a second stage of isolation. And that's the idea of SEM-base and stasis. They're not designed to be a primary vibration isolation system or a stand on its own vibration isolation system. They're designed to be a second stage of vibration isolation to complement and enhance and not fight with the internal vibration isolation systems that are built into the instruments. And where the internal vibration isolation systems are not very efficient at the very low frequencies, that's where stasis and SEM-base are at their best. So where they're at their best, they're complementing the Achilles heel, if you will, of the basic vibration isolation system that would be built into an electron microscope.
Interesting stuff. Okay. And on top of that, even though you don't create microscopes, obviously, and you act as a supplementary technology to this important industry, I know TMC does have some unique asks, right? Microscopes are used for a lot of different research, and microscopy is a wide field in terms of use cases. I'm curious if TMC works with microscope suppliers to help make more custom solutions for specific research needs.
Yes, TMC works with microscope manufacturers to design custom solutions, both designing isolators that are built into the equipment and provided with the microscope by the manufacturer. But we also do it for end users who might have various custom requirements for various reasons. So the capacity, the size, the shape, adaptations for various environmental problems, vacuum compatibility, non-magnetic materials, clean room compatible materials. So there are various ways that we customize these isolation systems for the electron microscope manufacturers and their customers.
Let's expand on that hypothetical here a little bit, right? So let's say a customer shows up to TMC. They have a very specific need, a very specific industry that they're working in. Let's say a very critical research industry, right? Let's say oncology or something. If a customer shows up and would like something tailored to their specific needs, what can TMC do about that, right? Do y'all offer customized solutions at that granular of a level?
Yes, TMC works with microscope manufacturers to design custom solutions, both designing isolators that are built into the equipment and provided with the microscope by the manufacturer. But we also do it for end users who might have various custom requirements for various reasons. So the capacity, the size, the shape, adaptations for various environmental problems, vacuum compatibility, non-magnetic materials, clean room compatible materials. So there are various ways that we customize these isolation systems for the electron microscope manufacturers and their customers.
And since we're on the subject of microscopes and microscope solutions, obviously there are other factors at play here beyond just vibration, right? Vibration control is key, but I'm curious if you can paint a larger picture here for us and how vibration control fits into that picture. Are there other things besides vibration that y'all see can hurt the performance of certain types of microscopes, and why is that important to understand?
So I'd say TMC is really unique in what we do, and that is there are other suppliers of vibration isolation systems, and there are people who are expert in this floor vibration isolation situation, vibration consultants, for instance. But there's no one that marries those two together, and that's really the vision of TMC, is that we're the world-leading experts in low-frequency, low-amplitude building floor vibration and how it disturbs ultra-precision instruments and experiments. But we're also a vertically integrated manufacturer that has our own engineering and R&D and is able to conceptualize and design one-off custom isolation systems. And it's those two capabilities that really set us apart. The ability to understand and vibration and design these advanced systems, and yet at the same time be able to make them quickly at low cost with high efficiency right in our headquarters in near Boston, Massachusetts.
Interesting. Okay. So how has TMC then solved for these non-floor vibration problems, which, are part of this larger challenge of isolating this important research? Again, how has TMC solved for this?
Well, one of them would be magnetic fields. And if you think about it, we're isolating electron microscopes from floor vibration by using vibration sensors and advanced feedback and feed-forward techniques to cancel vibration. Well, we use that expertise in control systems to do magnetic field cancellation, where instead of a vibration sensor, we use a magnetic field sensor, a flux gate magnetometer to sense magnetic fields. And we create, instead of an equal and opposite force to cancel vibration, we create an equal and opposite magnetic field in the X, Y, and Z axes using call it a pseudo-Helmholtz coil, by driving current through a coil to create a magnetic field. So in the same way we use our understanding of cancellation techniques of vibration using feed-forward and feedback techniques, we use those same techniques to design magnetic field cancellation systems that are inherently compatible.
Well, I always like ending things on an anecdotal level, so let's ground these discussions to a specific example. What are some real-world problems that you're seeing your end users, right, your professionals and experts and researchers? What kind of real-world problems are they solving in advanced microscopy today, and how is TMC contributing to that research, to those real-world problems? Give us an example or two of, more specifically, advanced microscopy applications that TMC has been involved in.
Well, one example would be the New York Structural Biology Center in Manhattan. New York Structural is a consortium between several universities and public research institutes in New York City. And they're one of three National Institutes for Health cryo-electron microscopy centers for excellence, along with Oregon Health Sciences University and Stanford Linear Accelerator. And when New York Structural was getting ready to house these cryo-EMs, there were vibration measurements that was made there. Now, Upper Manhattan, where this is sited near Columbia, is on bedrock, right? So it was a relatively quiet environment. And the environment was initially determined to meet the vibration specs of the tools. But because there were concerns about, well, what if vibration levels rise over time, right? It's a noisy environment in Manhattan. There's all sorts of construction and traffic and rail and subway things going on that could make things worse. The vibration environment can never be fully predicted. It can change. So the decision makers at New York Structural wanted to be conservative, right? They wanted to make sure that the vibration environment was going to be quiet, even if things got worse, because they didn't really know exactly what they needed. So they didn't want to take a chance. So what they ended up doing is they actually, with jackhammers, dug a 1 meter deep pit, if you will, in concrete plinth, and installed the stasis isolators supporting large platform tops that we had designed to match the footprint of the electron microscopes, which then supported the tools. And this was very successful. Ultimately, the vibration levels that we were able to achieve were extremely quiet, and were able to provide long-going vibration environment levels that are well within the specs of the instrument, and they were able to achieve the performance they were looking for.
All right, Steve, I think on that note, we'll go ahead and wrap things up. Thank you again for your time on the show today, taking some time out of the Microscopy and Microanalysis conference here in Minneapolis, and giving a little more insight into how TMC is staying on top of these key needs and areas of research in microscopy and microanalysis, and how the Stasis 4 is really stepping up and bringing a new level of vibration control and support for this important research. So again, folks, we've been chatting with Stephen Ryan, Vice President of Sales and Service for TMC, an Amatech business. Stephen, thanks again for your time. It's really been a pleasure. And thank you, everyone, for joining us on this very special episode of Vibrations, a TMC podcast. If you like what you heard and saw today, make sure you're heading to our website for a little more information, and subscribe to Vibrations on Apple Podcasts and Spotify so you don't miss any future episodes, and so you can catch up on our catalog of content. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on the next episode of Vibrations.